Hello and welcome to Power Test 24 conference hosted by NETA. I'm Ellen Parson, Editor-in-Chief of EC&M Magazine, and I'm here in Dallas for a two-day event to learn everything I can about electrical power safety and reliability. And I'm talking with some leading subject matter experts. One of the subject matter expert who was kind enough to take time with me today is Ramieh. He is with Group CBS. And Mose, thanks so much for taking time to break down the key takeaways from the presentation today, which is entitled A Customer's Perspective, Arc Flash Mitigation, If Only. So just to start off, arc flash is one of EC&M's most popular topics, obviously, whether it's print, newsletters, online, podcasts, videos. So I'm excited to get into this presentation to find out, to share some of these key themes with our viewers. So let's start off with, I know in the beginning of the presentation you talked about, your colleague said, if I had only known then what I know now, I would have done things differently in the early design stage. So maybe that sounds like a good starting off point. If you could explain that and how does that relate to arc flash mitigation techniques?
Yeah, I think that's a great starting point because that's what Randall basically had to learn over the years, right? Over the 25 years that he was with that facility. 25 years ago, we really weren't even talking a lot about arc flash just yet. I mean, it's been right at that cusp, right? Mm-hmm. So the design at that time didn't necessarily take that into account. And then over the course of time, then 10 years later, he would do an installation. How could he make that installation a little safer? What were the lessons learned? Then he would carry those forward to even the next installation. And every time, technology gets better, sure. We learn more lessons. And we continue to improve and once again try and create systems that are relatively safe, mm-hmm. and still be reliable to once again so that they can make cars.
And that's why this is a topic that's just over and over is so important, and people just want to read about it over and over. So let's start with the arc flash mitigation. Is obviously it's a topic that you talk about at all of these conferences. It's something that's in demand. Everybody wants to know about. So in general, would you say we're making progress? I guess I wanted to start there. And if not, where are we falling short, do you think?
Yeah, I think the industry has definitely made a lot of progress over the last, 20 years. So right around 2000 is when 70B started to really being something that was talked about. 70E was talked about a lot more. And, we are making progress, whether it's the education of the qualified workers, the signage and the studies that are being performed on our power systems to communicate what the hazard is to those qualified workers at various points. Lots of strides made there on the engineering. Obviously 70E and the engineers that work on that are continuing to refine how the calculations get done further, better quantifying the arc flash hazard. So in those areas, I think we're making tremendous strides. That's not to say that every facility is adopting that. I still go to facilities every month that you walk in and they either don't have an arc flash study or have not kept it up, right? Which, that face. Now, where we still have a long way to go is we are seeing, and especially in new medium voltage installations, we're seeing a lot of GIS gear, so gas insulated switch gear. And of course the beautiful part is if there's no exposed energized conductors, there's no arc flash potential, right? Mm-hmm. In theory, not that you should do this, right. But you could walk up and touch it because there's no exposed energized parts. So that eliminates the arc flash hazard. So we're seeing more of that gear, but I think there's going to be a long time before, because let's face it, everything takes time and money, right? And facilities don't have an infinite amount of both. So how can they, and that's just it, over time, new facility designs will incorporate this technology and we'll have even safer systems where eventually maybe we can drive arc flash hazards to be something of the past.
Wouldn't that be great?
Wouldn't that be great? But
right.
That's going to take a while just because, once again, the technology is still coming along, but it's gotten so much better, it's so much more reliable, and people are beginning to trust it. Although I did get a great question in the presentation from a young man that says, well, how do I know that it's working?
Right.
Right? What if the breaker doesn't trip like you think it's going to? Because then that low arc flash hazard may not be relevant. It might be it could be significantly higher.
Yeah.
So great question from that young man in the front row today, and my answer was, well, that goes back to, the 70B being a standard now, and that we need to do routine maintenance and make sure, and that applies to new systems, old systems, is the equipment working the way it was originally designed, and how the studies have calculated it to design, right? So if the breaker trips slower than the study says, then the arc flash hazard is going to be higher. And so that's definitely a few different areas
That's a great
that are
example.
for improvement. Yeah.
Yeah, all right. So going back to that design phase, why is it beneficial to incorporate that in the initial design phase? Like that to reduce like retrofits later or?
Yeah, I mean, I think like so many things, if you get the bells and whistles when it's brand new,
Yeah.
Yes, it costs more, but it doesn't cost. Well, I guess it costs less than doing it after the fact,
Okay.
right?
So
Trying to
that's
retrofit
always
something in.
Advantageous.
Right, it's advantageous, and of course, in a lot of cases, to install this equipment, you have to take outages, right?
Yeah, right.
So let's face it, if you could have it
Factor in all
installed before it's energized, then you don't have to de-energize it to install it. And like I say, if we could incorporate it up front, we can actually take advantage of some technology. I mentioned briefly that in a lot of situations we have switches in front of transformers, and the switches, because they're fused, create higher arc flash hazards downstream. And people have been removing fuses and installing retrofilling with circuit breakers. Well, there's transformer technology now that packages the vacuum interrupter technology with the transformer in the same enclosure, in the same box. And so then once again, going back to my point, if it's all insulated, if it's all encapsulated, we basically, not only do we have the advantage of having the false interrupter, but we also have the advantage of low maintenance and reduced arc flash potential to start with. It's all beneficial.
All right, well, I think we're about ready to wrap up. So let's end with you. At the end of the presentation, you had two conclusions, and one was the speed as a recurring theme, and then the other one was how some upstream protective devices can't be made to operate faster. So why are those so important, and what should electrical professionals need to remember when they're trying to reduce the arc flash hazards?
So let me attack the speed one. I think there's three levers that we can pull to reduce arc flash hazard. The first one is we can try and reduce the fault current that a lot of times is coming from the utility. The second one is we can increase the speed at which faults are cleared, right? If I shorten the time, then I have less fault current. And then the third thing is we can create distance from the fault. Well, there's virtually no case that I can really think of where we can easily, economically reduce the fault current, right? The fault current is what we get from the utility.
Yeah.
So we can't easily reduce that. We can reduce the time though, right? And that's using a lot of the technology we talked about, whether it's the arc flash sensing relays or using, once again, virtual mains or vacuum fault interrupters to clear faults faster. And that's, once again, some things like fuses, you can't really upgrade a fuse, but we can replace it.
Yeah.
And once again, do we have the relaying technology, right? If we've got a relay upstream of where we're trying to protect and it's got electromechanical relays, we can upgrade those, but that's just another thing that we have to replace. We can't make those work in this situation. We have to replace them. And then finally, the last thing that we control, and this is really more about the worker, not about the gear, right? If I can reduce the fault current, reduce the time, I can protect the gear and the people. But finally, if I can't do that to a point that's safe for the workers, then their best solution is to get away from the equipment, right? Distance is safety, and there's a lot of equipment out there that will allow for remote racking and remote switching of breakers that will allow the worker to get away. Now, unfortunately, that doesn't solve the problem if there's a fault that the gear can be damaged, but at least we're protecting the people. So all three of those things work together and work together to make a safer environment for both the equipment and the qualified workers.
Well, I think that's it for now. I'm Ellen Parson with EC&M at Power Test 24 in Dallas. Thank you and have a good day.